What are carbide burrs? Carbide burrs, also known as carbide burrs, are precision-engineered rotary cutting tools that play a crucial role in various machining and fabrication tasks, particularly in automotive and engine building. At their core, carbide burrs are made from tungsten carbide, a highly durable and hard material composed of tungsten and carbon atoms bonded together. This composition gives them exceptional resistance to wear, heat, and abrasion, making them far superior to traditional high-speed steel (HSS) tools for demanding applications. Tungsten carbide is sintered, compressed and heated, to form a solid, extremely tough cutting edge that can handle high-speed rotations without dulling quickly. These tools are typically small, with a shank, the non-cutting end that fits into a tool holder, made of steel for compatibility with standard equipment, and the working head shaped and fluted for cutting. The overall design allows for efficient material removal while maintaining control and precision. Carbide burrs are not disposable like some drill bits. They can often be sharpened or reground multiple times, extending their lifespan and making them cost-effective for professional use. In terms of construction, a standard carbide burr consists of shank, the straight or tapered portion that attaches to the rotary tool, usually 1/8 inch, 3 mm, or 1/4, 6 mm, in diameter for common die grinders. Cutting head, the business end, where the tungsten carbide is fluted or grooved to create cutting edges. The flutes can vary in number, angle, and pattern depending on the cut type. Coatings, optional. Some advanced carbide burrs feature coatings like titanium nitride, tin, to reduce friction and extend life, though uncoated versions are common for general use. Carbide burrs operate at high RPMs, typically 10,000 to 30,000 RPM, generating heat during use, so proper cooling, like using air or lubricant, is essential to prevent damage to the tool or workpiece. Role of carbide burrs in cylinder head porting. Cylinder head porting is a critical process in engine modification and performance tuning, where the intake and exhaust ports in an engine's cylinder head are reshaped, enlarged, or smoothed to improve airflow. This enhances volumetric efficiency, allowing more air and fuel into the combustion chamber, which can boost horsepower, torque, and overall engine responsiveness. Porting is commonly done on aluminum or cast iron cylinder heads for applications like racing, custom builds, or restoring vintage engines. Carbide burrs are indispensable in this process because they provide the precision and durability needed to work on hard metals without excessive vibration or tool breakage. Unlike files or sandpaper, which are slower and less accurate, carbide burrs allow for controlled material removal at high speeds, enabling porting jobs to be completed efficiently and with minimal risk of overcutting or damaging delicate areas like valve seats. Here's how they fit into the workflow of cylinder head porting. Initial roughing out. Larger carbide burrs are used to remove bulk material from the ports, enlarging them to the desired shape. This might involve scooping out restrictions or blending curves for better flow dynamics. Shaping and contouring. Specialized shapes allow for following the complex geometry of ports, such as creating smooth transitions from the manifold runner to the valve throat. Smoothing and finishing. Finer burrs refine the surfaces, reducing turbulence by eliminating rough spots, casting flash, or imperfections. This improves airflow velocity and reduces restrictions. Valve seat and guide work. Smaller burrs can chamfer edges or clean up areas around valves without altering critical tolerances. The key advantage in porting is their ability to handle both aluminum, softer and prone to galling, and cast iron, harder and more abrasive, heads. For aluminum, burrs prevent material buildup on the tool, while for cast iron, their hardness resists chipping from embedded sand or impurities. Shapes of carbide burrs. Carbide burrs come in a wide array of shapes to match the contours of cylinder head ports. Common ones include cylindrical end or plain end straight-sided for straight cuts, deburring, or enlarging straight sections of ports. Ideal for initial material removal. Ball nose or spherical rounded end for creating smooth radii, blending corners, or undercutting without flat spots. Great for smoothing port bowls. Flame, tapered with radius end tapered shape with a flame-like tip for accessing narrow areas or creating gradual flares in exhaust ports. Other shapes include egg, oval for blending, tree, tapered for angled cuts, cone, pointed for precision detailing, and rotor, for curved surfaces. Each shape is denoted by a code, e.g., SA for cylindrical, SC for ball, in standard nomenclature like ANSI or ISO. Choosing the right shape depends on the port's design. For example, a flame burr might be used for the diverging section of an intake port to promote even flow. Cuts, flute types, of carbide burrs. The cut refers to the pattern of flutes on the burr's head, which affects cutting action, chip evacuation, and finish quality. Single cut features straight, parallel flutes at an angle, usually 0 to 14 degrees. This produces long chips and is best for softer materials like aluminum, providing a smoother finish but slower material removal. It's aggressive on non-ferrous metals and reduces clogging. Double cut, cross-cut as intersecting flutes, one right-hand helix and one left, creating smaller chips for faster stock removal and better control. Ideal for harder materials like cast iron, as it breaks up chips to prevent packing. However, it can leave a rougher finish, so it's often followed by single cut for polishing. Diamond cut uses diamond pattern flutes for ultrafine finishing, producing minimal vibration and a polished surface. This is premium for final smoothing and high-performance porting, where airflow efficiency is paramount. It's slower but excels at removing minimal material without gouging. For cylinder head porting, a combination is often used: double cut for roughing, single cut for aluminum smoothing, and diamond for final touches on both metals. Safety and best practices. When using carbide burrs for porting, always wear PPE, eye protection, gloves, respirator, due to flying debris and dust. Secure the cylinder head in a vise. Use variable speed tools to match RPM to burr size. Smaller burrs need higher speeds, and avoid excessive pressure to prevent overheating or burr breakage. Regular inspection for wear is key, as dull burrs can cause poor cuts or kickback. In summary, carbide burrs transform cylinder head porting from a labor-intensive chore into a precise art, enabling enthusiasts and professionals to unlock hidden performance potential in engines. For our full selection of high-quality carbide burrs specifically designed for cylinder head porting, visit our website today to browse shapes, cuts, and kits tailored for automotive use. And to get 10% off your purchase right now, use our coupon code below at checkout.